Zoom recording. I am running a Zoom. This Zoom is for people really who are outside of the classroom, who are sick, who are in quarantine, or have student access accommodations. If you are on quarantine or sick, there is a particular form that the university requires that you fill out. And I have a link to it on my Moodle page. You have to fill out the form. Then you will get a excuse, a university excuse, and then you need to forward me that excuse, okay? So to not be here present physically in the classroom, I have to have some kind of a university approved excuse. And that's university policy, not my policy. But if you are sitting here in the classroom and you want to have my screen right in front of you, you have your computer, you want what you see on the screen right in front of you, you are welcome to join the Zoom. But just make sure, two things, make sure your microphone is muted and your audio output is muted. Because if not, we're going to get a ton of feedback, and it will be unpleasant. I also try to have the chat box up. So you're welcome to ask, raise your hand and ask a question, or you're welcome to throw a question up in the chat. If I don't see it right away, please tell me, like, hey, Dr. B, somebody's asking you something in the chat, and I'll catch it. But you're welcome to join if you would like. So let me introduce myself to you. I am Dr. Sarah Bergeron. Lots of people call me Dr. B. I'm good with that. Professor Bergeron, Professor B, mostly it's Dr. B, but either is fine with me. I have spent my life trying to decide what I like more, biology or chemistry, and what I have finally decided is I love them both. So I am a biochemist. So I have my my bachelor's in science in microbiology with a chemistry minor. Then I went and got a PhD in molecular and cellular biology from the University of Iowa. And I got that from a biochemistry lab. So all of the research that I did was all biochemistry, but took a combination of chemistry, biology classes. And then I realized not only do I love biology and chemistry, I also love teaching. So I was like, well, I'm gonna go get a master's in teaching. So I went here to Nichols and I got a master's of art in teaching in secondary science education. So I really love what I do. I love teaching these subjects. I know people hear chemistry and they're like, oh, chemistry. But I really think it's a lot of fun. And I really think that you're going to learn a lot and you're going to be able to apply what you learn here to your professions, your allied health professions, and you're going to be able to take it with you in the long run. Everybody, please, please, please take your mask and cover your mouth and your nose with your mask. Y'all, I want to be here on campus. I do not want to go on Zoom with all of my classes. What we can do, every single one of us can do, is to wear our mask properly every day, the whole time that we are inside of a building. If I walk away from the podium, I'm going to put my mask on. I'm only wearing the shield because I'm also behind the plexiglass. But we want to stay safe. We want to stay on campus. So wear the masks and please get vaccinated. It is going to be the best way that we can all stay on campus. All right, let's see. What else? I always forget. Oh, see, this is why I do this slideshow, because I want to remember the things. So what I want to tell you, number one, is that I've got your back in a good way, not in that kind of way, but in a good way. If you need something, please tell me. Dr. B, I don't understand. Can you slow down? Wait, I was doing my homework. I didn't get this. I need help. I'm never going to say, oh, you're on your own. I'm never going to say that. I'm always going to help you. But that help comes with you also helping yourself. You have to do the work for this class. I love this class. I love this subject. Is it the easiest class? Is this going to be one of those, like, breeze through, like, I don't know, my choral music class that I took as an undergrad over the summer? No, it's not. But when you put the work into it, you're going to get a lot out of it. So the more you help yourself, the more I can help you. okay? But you have to put the work into this class. You have to. It's a daily thing. You have to find a schedule that works for you and work on it every day. Get in that mindset and you're going to be very successful. You will be. So I'll tell you a little bit about myself. I have a little boy. He is 9. It's Charles in the picture, who I go and pick up at 3 o'clock every day. He is very much into Legos and jokes right now. So I like to start every single class with a joke. You are forewarned that these are 4th grader jokes. And that is going to be the quality for the remainder of the semester. So, what kind of shoes do spies wear? Sneakers. And it's going to be that high quality all semester. So if you don't want to hear really bad 4th grade jokes again next semester, start studying. Otherwise, you have to hear them all again. So the other individual in the picture is the recent addition to our family over the summer. That is Rosie. Rosie in that picture is 4 months old at 40 pounds. She is a Great Dane. She comes to work with me every now and then on the weekends, stuff like that. So if you see a really big dog, it's probably mine. I'll have to give y'all some update pictures, you know, as the semester goes, because she's going to get enormous. All right, so you don't have to do it today because I know some people, the iClicker is not working, but this is how we'll start off class with an amazing joke and attendance. So you have to stay in the seat that you are sitting in for the remainder of the semester. You have to. And I'll ask you to click in. Are you present in the classroom? Are you virtually online? We already have a few people who are out on quarantine and things like that. So it's important that you let me know if you are in the classroom or if you are remote at home. So that'll be our first iClicker question that will start on Thursday, but not today. We're not going to do it today because we have a lot of things that aren't quite working today.
So for today, if our iClicker wasn't working, we have to sign in.
If your iClicker was not working, if you do not see yourself on this list and listed as present, then you need to sign in there. But I didn't start the question. The question's not open, so there's nothing to answer. I just showed it on the screen. I didn't actually create an iClicker question. So there's nothing to actually buzz in with. Okay, so just because you turned your iClicker on, you should have automatically joined the class if you have a handheld clicker. Okay, does that make sense? Okay, and it might be, did you register on the iClicker site?
I just did.
Okay, so it just might take a few minutes. I'm going to leave it run all class period, and then we can recheck at the end of class. Okay. I'm happy to do that. Okay. And I'm happy to, like, if y'all want to shoot me an email, if I have to run, Dr. B, can you check to see if I was present? I can go back and check and then send you an email. Yeah, no problem. Okay. Any other questions? All right. So how many times have you seen something like this before? Pretty regular, right? You've seen that before. Scientific method. It's not something new, but it is something that I want you to be able to use when you leave here, because the knowledge that you're going to gain here is going to be really important for how you evaluate situations in your professions, right? You're going to have to look at things critically. And so you have to be in the habit of asking questions, of making observations, making conclusions from those observations, and even changing what your conclusions are, right? We've done that lots with the vaccine lately, right? We made some conclusions and now we have to change. We thought, hey, you get vaccinated, then you don't have to wear a mask. Well, guess what came around? Delta. We have a new variant, right? And now, even if we're vaccinated, we could be spreading coronavirus. So that's why we're remasking. So it's really important to take that information and to change your conclusions. There's nothing wrong in science with changing your mind, right? That's the responsible thing to do. To say, hey, we got new data and that changes our recommendations, and that's a good thing. So I want you to make some observations and draw some conclusions today. Okay, so one of these cans. All right, so I have this can of Coke, right? If you're on Zoom, I'm sorry. I have this can of Coke, I have this tank of water. If I put this can of Coke in the water, what do you think is gonna happen? Sink is one possibility. It's another possibility. Float, sink or float, right? So we have a research question. You made a hypothesis, sink or float, whichever one you chose. So now we have to do our experiment, right? So we're going to do our experiment, make sure there's no water in the bottom. It's going to happen. Sink. Okay. All right. So now I have another question for you. Sink or float? Take a guess. I'm not grading it. I promise I'm not grading it. All right, so I'm putting it, I don't want the bubble at the bottom to change our results. What happened? Floats. Okay. Why does something sink or float? Density. So I heard mass, I heard density. What's density dependent upon? The mass and the volume. Density is equal to mass divided by volume, right? Okay. Tell me what's different between a Coke and a Diet Coke. If the density is different, one of the two parameters has to be different. Is the mass different or is the volume different? They're both 12 fluid ounces. So it must be what? Mass. Why would the mass be different in a regular Coke versus a Diet Coke? What's in regular Coke? Sugar. How much sugar? 39 grams of sugar. 39 grams of sugar. Do we have sugar in a Diet Coke? But it tastes sweet. There's an artificial sweetener called aspartame inside of Diet Coke. The cool thing about aspartame is that the same amount of aspartame versus sugar is way sweeter than sugar. So if I put 39 grams of sugar in a regular Coke, am I going to have to put 39 grams of aspartame in a Diet Coke? Oh, you wouldn't want to drink it. Trust me, it would taste horrible if you put 39 grams of aspartame in one Diet Coke. It would be disgusting. So how did that affect the density? We have more or less mass in a Diet Coke. Less mass. We have less mass in a Diet Coke. That's right. Okay, now we know that that changes density. What do we have? Can of Coke. So if I put this can of Coke inside the tank here, what's going to happen? Only two options, right? Sink or float. What do we think? Sink? Anybody want to die regular Coke? Anybody? No? No takers? What's going to happen if we open this? This is going to explode. All right. Well, should we put it in the tank? Okay, so what's going to happen if we put it in the tank? It's going to explode. It's not going to explode. Oh, what happened? Pressure doesn't change density. So I put air in there? Oh, wait. I heard what?
The air molecules got excited and came out of the water.
So what kind of gaseous molecules? It's not air. What kind of gaseous molecules? You're right. They came out of solution. It's carbonated. So what kind of gas has carbon in it? Carbon dioxide. So there's actually carbon dioxide dissolved inside of the water of the Coke and the Diet Coke that make it fizzy, right? We all love some fizzy. Tastes great, right? Okay, so I dropped this Coke on the ground, and not all of them, but a lot of the carbon dioxide comes out of solution and actually ends up clinging to the sides of the can. And what happens to the shape of the can? What do you see? Do you see how it's like bulging out, right? We actually bent the can. So what did we change when that gas came out of solution? Volume. Does volume affect density? Cool, right? So if you ever, I don't know about dropping, I don't know how effective it would be, I'm not going to try it in here. But if you ever have somebody shake up a can, right, and give it to you, right, you know they've shaken it. Where did I say all the gas particles are now? Attached to the side. So if you take it and you basically thump the sides of the can, what you're actually doing is you are making those gas particles go back into solution. And the ones that don't actually rise to the top. And so you end up having less of an explosion. Is it going to be perfect? Probably not, but you'll have less of an explosion. Kind of cool, right? Okay, so that same thing that you did just with Coke and a fish tank, right? I want you to use those same powers of observation and application, right? You took the information from a change in mass and interpreted that to a change in density. You did the same thing with volume. So what we learn in one situation in science is a lot of times very applicable to other situations. So don't think about your sciences as these individual things that you have learned. They're all interrelated and they're all dependent upon one another. So, and if anybody wants a Coke, there's three classes today. If anybody wants to risk it. No takers? Imagine that. All right. Okay, so what are we going to do for the rest of the class? Well, I want to show you around a little bit in our Moodle site, and I want to show you a few things in our syllabus. I am not going to read the syllabus to you. I know that you know how to read the syllabus, so I'm not going to read it to you. I just want to pick out some important things. And you read, let me move this back. You read the welcome letter and watched the little How to Succeed video, right? Everyone should be nodding their heads, everyone. A lot of people did, which is great. You know that this is a flipped class. So what happens in a flipped class is at home, you're watching the lecture. Because for me, I know that you can sit and listen to a lecture, right? But what happens when you go on your own and you start looking at problems? A lot of times that's where you run into an issue. You're looking at this problem, you're like, I don't even know where to start. What do I do? Well, I like to be here with you when you get to that point. So that way I can model what to do and then you can do it. So I find I want to be here when you're struggling the most. So when we're doing problems, always try them with me. Do you get the same answer that I get, right? You just sitting there copying what I'm doing is not going to get you to learn. You have to try while you're in class, okay? All right, so how do you know what videos to watch? The class calendar, which is on Moodle. And I'm going to show it to you in just a minute. It's updated daily. So if something changes, we go online. A hurricane hits, knock on wood, right? I don't want any of those things to happen. But if something changes, I update it daily. So it's always, always, always correct. And then I always want to tell you to have a good day. And I don't want to forget that. So, you know, with the rest of your day, have a great day. All right. So let's go to Moodle real quick. All right. So this is what you should be looking at when you log into Moodle. And if you have a handheld iClicker, if you have not done so already, you should register your iClicker there. I want to switch to demo student because I want you to see exactly what you normally see. Okay, at the very beginning, this is how you get in touch with me. right? I said, always call me when you're having a problem, when you're struggling, when something's going on. This is how you contact me. I'm in the building. I'm in room 132, just coming down the hall. This is my office phone, my email, and I gave you all access to my calendar. So this is my calendar. You can pick any day that works for you, and you can go in and you can make yourself an appointment with any open slot. So you don't have to email me, hey, Dr. B, are you gonna be, you have my entire calendar and all of my openings at your fingertips, and you can book an appointment that works for you. So you would pick whatever time you like, put in your information. Then all of my office hours this semester are on Zoom, but if you would like to meet in person, I can find an empty classroom and we can use an empty classroom. But my office is small and my son is coming to my office every afternoon. So I'm not having any meetings in my office. But if you want to meet in the classroom, more than happy to do that. Let's say you're doing something with you and 2 of your classmates and y'all have the same question and want the same help. We could get on a Zoom with 3 or 4 people, right? A classroom with 3 or 4 people, doesn't matter, right? So there's lots of flexibility in this. This is the most important part right down here. Please share something that will help me prepare for the meeting. So tell me what problem you're having. I need help with chapter 1, section, whatever it is, these kind of problems. I'm having trouble with the online homework. I'm having whatever it is. Tell me so that we make the most out of your time and the most out of my time. So we get you the most amount of help, okay? All right, so that's, I was gonna move that. All right, so that's how to get into contact with me. So when you look at the rest of the Moodle page, which you'll see is course information, which is what we'll go over today. And then each of the remainder of all the material is grouped into units, and those units correspond to course material. So exam 1, how many chapters are on exam 1? Only 2. So guess what? Your first exam is coming up real soon. So don't get behind. I do this for a reason. I want you to stay on top of the material, and I want you to have your beginning exams not have a whole lot of content on them so that you can be successful. So basically every way that I design this class is to make you successful, but you have to take advantage of it, okay? So everything that you need for unit 1, chapters 1 through 2 are here. We have some beginning mini homeworks to accomplish. Then the lecture slides that go along with the videos. If I could make this just a little bit bigger, that'd be great. Right, are right here. The in-class problems that we're going to work together in class are right here. And then all of the lectures that go along with that chapter are right there. So everything you need for chapter 1 is right there. And I have even some extra things sometimes. Now, when we have the exam, you're going to get things on the exam. You're going to get, I call them resources. So if you want to know what's going to be provided with your exam, click on that link. Guess what you're going to get on the exam? A periodic table. You're also going to get the elements in alphabetical order, because sometimes those symbols don't match with the element names. Have you noticed that? Like sodium, what's the symbol for sodium? What's up with that, right? So sometimes you get a little confused. That makes it easier. And if you have a hard copy of the textbook, I pulled this from the front and the back of your textbook. That's where all this material is from. So this is all the material that you get on the first exam. My suggestion is you print it out. You have it next to you in class. You have it next to you at home when you do your homework. You have it wherever you do chemistry. That way, when you get to the exam and I hand it to you, you're really comfortable with it, okay? All right. Let's see. All right, so we're going to hide unit 1 for now. We're going to just look at course information. Did everyone get a notification from me today that I posted something in the general course questions forum? Raise your hand if you got an announcement from me. Oh, that is not a lot of people. Okay, so that means that most of you need to change your preferences. So you see this little symbol over here of the person? you click on that and you click on preferences. Under user account, come down here for notification preferences. I have like everything on email on, everything. So the one we're really looking for is forum, because this is how I'll get you guys information. And you need to make sure that whether you're online or offline, you're going to get an email. Okay. So you need to make sure that you have your preferences set. Okay. Let me go back. All right. You should have all read the welcome letter, watched the video. So here's our syllabus. There's a few things I just want to point out in our syllabus. The same ways that you can contact me that are on the Moodle page are on the syllabus. Let's see. You should have access to your textbook. Was everybody able to access the textbook? Yes. You know that you access the textbook always, 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 whether you're reading it, if you have an ebook, or if you're accessing homework. You have to use this link right here, course materials. You click on that one, and then if you want to read the book, see if it loads. If you want to read the book, it's read now. If you want to do the homework, it's lunch courseware. Okay, all right. You also need a calculator. Like the $10, anybody got one of those $10 calculators from Walmart, right? It's a TI or a Casio. So long as it does like the log and that kind of thing. Yes, like that. Can you hold it up for us? Just like that. It's like $10. Really easy to use. Now, if you've spent $100 on a TI 80 fill in the blank, you're welcome to use that too. But my instructions are probably going to go along with that $10 calculator because that's what most people end up having. Okay, but you can use any calculator for exams. But my suggestion is you use the calculator in class and on your homework that you're going to have to use on the exam. So if you forget your calculator one day in class, can you do your calculations on your phone? Sure, I don't care. But come test day, exam day, you're using only the approved calculators. Okay, so get comfortable with those calculators. And guys, everybody please put your mask all the way over your nose for the whole time. All right, let's see. Everything you'll need to access on Moodle, and then your iClicker. So if you have iClicker problems at the end of class, we'll come and see if you're checked in, and if you're not, then we'll know that we need to work on getting you set up with iClicker. Okay. Did anybody talk to y'all about the book bundle program? Yeah, they told y'all that it's a rental, right? Okay. Some people I noticed didn't know that. So if you participate in the book bundle, it is a rental. So you have to either give back the hard copy or your access to the ebook will be cut off at the end of the semester. Okay, so if you're trying to decide which one you want, know that the bundle is a rental. And if you want to opt out, you have to opt out by the 20th of August. Questions on that? Okay. All right, so I'm going to scroll down because that's all, you can read all that stuff. All right, I want to show you this. All right, what is your grade dependent on for this class? Number one is regular exams. So exams during the semester. I will give you 4 exams, but I'm only going to keep your 3 highest exam scores. That's pretty awesome. So do not say, I don't have to study for the first exam. It's like the easiest material, right? I don't need to worry about that. Don't do that. Please don't do that. Get your good grades in the beginning. So if something happens later, you're okay, right? Study hard for all of them. And then whichever one you struggled with the most, that's the one we drop, okay? So be careful with that. You have homework, which is mastering chemistry. So you have 1 homework for every chapter we're going to cover, which is 10. Now, inside each of those homeworks, I built in a couple of extra questions. Those extra questions are bonus points. So every time you do your homework, If you do all the questions, you gain bonus points. Okay, so over the semester, they add up. Trust me, they add up. We have a couple of mini homeworks in that first unit, and then you have iClicker questions. So we'll have a couple of iClicker questions every day in class that starts on Thursday. They can be on videos, content that was in the videos that you were supposed to watch before you came to class, or from stuff we did the class before. All right. It is worth 100 points. It's the same point value as one exam. That's a lot of points just for participating in class, right? So do your iClicker points. And, you know, I know that you're not going to get everyone right. I realize that. So for iClicker, a 70%, like if you're keeping track of your iClicker on your phone or on the website, and you go in and you see, oh, I've only gotten a 72% on my iClicker, right? So that's a C. That's not. 70% or higher is an A in iClicker. And then it breaks down by 10 points, just like a normal 10-point grading scale. Because I know you're not going to get everyone right. We're still learning. So I've curved it. Okay. So at the end of the semester, if you send me an email that says, Dr. B, I'm so close to a fill in the blank with whatever grade you really want, can you just bump me up? What am I going to say? I'm going to say no, but I'm going to remind you that during the semester, I dropped your lowest exam score. I gave you bonus points in every single homework, and I made your iClicker score 70% an A. So I'm not bumping anyone up, okay? So take advantage of what I'm offering from the start so that you don't have to be put in that situation at the end, okay? And you don't want to hear fourth grade jokes again, right? You don't want to do that. All right, and then we have a comprehensive final exam. So what does comprehensive mean? Whole semester from today to the last day of class, that's what's on the final, everything, okay? And then I do, your final score is your whole number grade. So I round it. I don't know if I fixed that on Moodle, but I will if I didn't. But it's a whole number. I don't go to the point hundredths or, you know, I know nursing sometimes goes to like the thousandth or something like that. It's kind of crazy. But I round to the nearest whole number. Okay. Let's see. All that stuff. Okay. I do recommend that you keep a notebook. You can keep a binder if you prefer a binder, but I really think that you should print out the lecture slides, right? So as you're watching, you can write on them. You print out the in-class problems that we're going to do in class so that you can write on them while we're in class. And then the online homework, let's say you're struggling with the online homework. And you send me an email, Dr. B, I'm on number 13. I don't know what to do. How do I help you? I can't because I don't know what you're doing. So if you have a notebook and you're doing the problems in your notebook, you can take a picture of your notebook and say, Dr. B, I'm working on number 13. This is what I've got, and I'm not getting the right answer. Can you help me? Then I can look at your work and go, oh yeah, you just switched the numerator and the denominator. Easy fix, right? I can look at your work real quick and help you. So the more information you give me, the better I can help you. So having that notebook is going to really help. Okay, that's the general calendar. You're good. We talked about iClicker. Let's see. We don't need to go over class rules. We're scrolling through. I know it's a really long syllabus. I know. All right, if you send me an email, please, please, please tell me what class you are in and tell me in the subject line, your class, your section, and like homework help, iClicker help, whatever it is. Because I teach a bunch of different classes. So then I know which class, you know, you're coming from, and I know where to go in Moodle and all that kind of stuff. Okay, let's see. Oh, okay. This is a really good one. Let's say you haven't had chemistry in a long time, or you took chemistry in high school and it sucked. You know, like, you know, oh, I'm going to need help on this, right? I'm absolutely available. But if you know that this is something that you're probably going to struggle with, the Tutoring Center is awesome. So on campus, you can get tutored for $25 per semester per class. That's cheap. And you can make regular appointments. Like if you know this is something you're going to struggle with, make yourself an appointment twice a week with the Tutoring Center. You can get the same tutor, you can go to different tutors, and you stay on top of it so you don't get behind. Because the thing with chemistry is it builds. If you miss something in the beginning, it's really going to bite you in the butt later if you didn't get it. So go to the Tutoring Center, ask me for help. Use the resources that you have to be successful, okay? All right, let's see. And that's in case of emergency, yada, right? Okay, and the last thing I always like to put on all of my syllabi are some extra resources, right? I know a lot of y'all are first-time freshmen, and you might not know where to go to get help for various things that happen when, you know, your life changes completely, right? So here's a list of just different resources that can help you out. Now, I'm not saying that you can't come to me. You can come to me with a homework question. You can come to me with a personal problem. I will help you as much as I can with whatever it is. So please feel free to contact me anytime. I'll do everything that I can to help y'all out, okay? All right, any questions on the syllabus? Good, all right. Okay, and I think we have a few things left in here and then we'll actually be able to do chemistry, finally. In each of the units, I have embedded the videos that go along with those chapters, but if you wanted to see all the pre-recorded lectures, this is just a link to the YouTube playlist, so you can kind of jump around and find what you want. If you're having iClicker problems and you have not come to this iClicker section right here, please go to it. I made a video that walks you through how to set up your iClicker. So that's a good resource. Now let's say you want to know, what do I need to make on exam 3 to go into the final with a B, right? Whatever it is. You can download this final grade calculator and you can put in what you think you're going to make and it'll calculate your final score. But you have to download it. So it'll be available all semester. Due to COVID, there's a new reporting form for this semester. So if you do go into quarantine, you do test positive, this is the form that you would fill out in order to get that excuse. We are 5T, so this is our Zoom meeting. If you do happen to be out, this is the one. Don't click on 4T, click on 5T. Okay, so y'all are all 5T. Make sure you write that down. Make sure you know you are 5T. So remember how I said, I want you to like your seat. I want everybody to go to Moodle right now and click on this 5T seating chart. Click on the 5T seating chart, not the 4T. If you pull it up and there are lots of names already, it's the wrong one. Click on 5T. You are going to put your name in the yellow spot that corresponds to your seat. I'm going to walk around and tell you what letters and everything. So, right, y'all are A, that's like 1A, right? B. If you have an empty seat in front of you, there should be an empty cell, an empty yellow cell. So you're C, D, E, F, G. Now in the back, everybody in this first row, y'all are number 9, right? So all the way over here to A, then your B, C, D, E, F, G, H. Cool? Type in your name. If you want to change seats, there's an open seat, tell me I have to update the seat. Yeah, make sure you leave empty seats. Your empty seats should be. Okay, while y'all are doing that, questions? Okay? Okay. While y'all are doing that, I want to tell you one thing. So homework A is in Mastering Chemistry. That's in the online textbook. That is going to be due, that's not, yeah, this Friday, August 20th. It's all about how to use the online system. It's a little confusing when you start. Once you start doing it, you'll get in the swing of things and it won't be bad. But in the beginning, you have to kind of learn how to use the system. So that's what this homework is. You will not lose any points for getting things wrong in this homework. Okay? So even though it will say, oh, incorrect, you didn't lose any points. This is just for you to learn the system. So you have to go through all the questions, but you're never going to get points off. Okay? Now, B is updating your profile picture and filling out a course agreement form. I had a problem with the original course agreement form, so I had to post a new one this morning. So I apologize, but if you filled it out before this morning, about 9 o'clock, you gotta do it again. I'm sorry. So once you read the syllabus, fill this out. But it's not due until next Wednesday. Yes, next Wednesday. Okay, good?
Do we have to print that out and give it to you?
Nope. You just fill it out. It's an electronic one. Trying to do as little paper as possible. I say that and then I'm going to give you a sheet of paper. I really am. Okay, so I have one chemistry thing that I want you to do for me. I'm going to put that stack. Here we go. Okay. Yes, ma'am.
So for homework A, I looked like for the instructions to bring it up, and it doesn't have my lab and mastering tools like on my page.
No, so in order to access mini homework A, you have to go here to course materials.
You go on the book.
So you go on the online homework system.
Just like the picture that posted, like it said like the little thing, like my lab, whatever. It's like it doesn't have that on ours. But
Oh, it doesn't have it on yours. Oh, okay.
it doesn't have the little.
This is my first semester with it integrated like this. So it's different. So I don't know what, okay, so I'm going to update that. Thank y'all for telling me. I'm going to update that.
Okay, so you go to the book. And
You go to the book and then you go to launch courseware. I will fix that this afternoon. Thank you. I don't know what it looks like on y'all end. Thank you. Okay, I am going to hand you something. So you need a pen. I do not want you to look online at any resources. You will need your N number. So if you need to look up your N number, you can look up your N number. This is not graded. I'm not grading this. There is no right or wrong answer. This is just for me to get to know you a little bit more. No right or wrong answers, but do not share your answers with your neighbors. Put up your arm, hide your paper, okay? Do not share answers. Read the question, answer it to the best of your ability, and that's it, okay? Turn it over when you're done. I'm gonna. All right. Now, no, I have to have it licking your fingers, right? How gross, like how gross is it, the things that we used to do, and now you're like, oh my God, that's horrible. I'm gonna give John, we're gonna give this row enough for both of those 2 rows, okay? If they're extras. So you need your N number, and I'm like, I'm not worried that y'all, you can leave your computer open, it's okay, you're not gonna cheat, it's not graded, it's fine. Oh yeah, pen or pencil, anything, yeah. I don't care if it's green or purple or whatever. What is the writing influence? Write your name. I'll show your answers to anybody. But I'm not grading. Don't grade it wrong. And when you're done, just flip it over. Give y'all about another minute. Anybody need more time? Okay, y'all can pass them up. Thank you. Thank you. All right, now I got some reading material tonight, right? Okay. Remember, no right or wrong. Okay. Not so bad, right? Wasn't too painful. Okay, and those of you who are on Zoom, I'm sorry. All right, so I'm not actually going to give you the answer right now. How terrible is that? Mean. We'll get there, I promise. All right, so before we can really talk a whole lot about chemistry, we kind of have to talk about matter in general and how we classify matter, right? Because it really gives us our vocabulary that we're going to use for the rest of the semester. And I know, excuse me, I know that science can be kind of like a foreign language, right? Science is a second language. It really kind of is, you know, and if I ever get off on the jargon, just tell me to come back to earth, like Dr. B, can use some regular language here. But it's important to learn that vocabulary so that you then use it correctly and things make sense later on down the road. So if we start with matter, all of matter, right? We can separate all of matter into two things. We can separate it into pure substances and we can separate it into mixtures. So for me, the easier thing is to know what a pure substance is. So if you think about a pure substance, what are you thinking of? Like generally, it doesn't have to be like the perfect scientific definition. I'm not looking for that. Salt would be an example of a pure substance. So it's one thing, right? It's something that we can clearly define and it is therefore pure, right? So salt is a really great example of a pure substance. So he said salt and I wrote NaCl. What is NaCl? Technically it's sodium chloride, but why did I put these letters instead of just writing salt? We know it's a compound. We know it's a compound because this is our chemical formula, right? If we can write a chemical formula for something, and I could say it's all this one chemical formula, then it all must be the same thing, right? So it all must be a pure substance. But can we get smaller? Sure, right? What if we just had Na? I just have sodium, right? And you could put this as sodium chloride, right? So if I just have sodium, then that's telling me I might have 10,000 sodium atoms. I might have one sodium atom, but they're all sodium atoms. So what do we call that? No matter how many you have, if it's all the same atom, it must be the same element. So this is the element symbol. So if you are a pure substance, you either have a chemical formula or an element symbol, right? So an element symbol, the easy way that I think about that is, are we going to stay in one square on the periodic table, right? So this is one square in the periodic table. What if I give you Br2, supposed to be a B, Br, not BV, Br2. Are we on the periodic table? Yes. Am I a pure substance? Absolutely. Am I a compound or am I an element? Why am I not a compound? There's no other element. It's all bromine. It's all Br. So I stayed on one square. If I stayed on one square, I'm an element. So this is one square of our periodic table, right? So this is one symbol. But if I'm a compound, I'm going to be some combination of multiple squares on the periodic table, right? So compounds, these are our chemical formulas. And FYI, I'm a horrible speller, did not get a PhD in spelling, so you can laugh all you want. Go ahead. I'm going to misspell things. All right. So for me, when I'm looking at trying to classify matter, I know if I'm finding it just in one square on the periodic table, that's an element. That's a pure substance. It's all that one element. If I have a compound, then I'm looking at multiple squares on the periodic table are combined chemically together, and we're always going to see that same formula. So for example, if I say table sugar will always be C12H22O11, always, always. Water, what was our chemical formula for water? H2O. If I have H2O in here, right? It's still water. What if I boiled it? It's steam. Is it still water? Yes, it's still H2O. What if I freeze it? Still H2O, right? I'm only doing physical things to change it, but have I changed the chemical composition? No, right? Those are compounds, okay? So the other way that we have matter on our planet is as mixtures. And a mixture, right? You're going to mix things together. So I would very easily say two or more substances, right? But that's an incomplete definition. Two or more substances is true. But you told me that salt is a compound, right? What if I put a little salt in my water bottle? Would I have a pure substance or a mixture? I would have a mixture, okay? I can't look at the water and tell it's a mixture, right? So how do I define that? I have to then be able to separate the components. So two or more substances that can be physically separated into the components, right? So if I had salt water, God, that'd be gross to drink, right? How would I separate it out? I'd boil the water, right? You could collect the water, collect the steam, right? And then it would condense back into water. And then at the bottom of my pot, what would I have? Salt, right? Okay, was I able to physically separate the two? Yes. Did a chemical change happen when I boiled the water? Did water change? No. Did my salt change? No. So that was a physical change. Okay. Anything that's a mixture has to be separated by physical means. All right. So there are two kinds of mixtures. We can have homogeneous mixtures and heterogeneous mixtures. Homogeneous meaning it's the same throughout. Heterogeneous meaning what? We can see different components. And when I say see, it's a little tricky, right? So salt water that we don't want to drink, what kind of a mixture would that be? Homogeneous, right? If you stirred it, right? If you didn't let it settle, if you actually stirred it, it would be homogeneous. Okay, what if instead of salt, I put sand in my water? God, I'm doing terrible things to my water today, right? So if I put sand in my water here, homogeneous or heterogeneous? Heterogeneous, right? Because I can see a layer of sand. What happens? This is what happens in all of our rivers and stuff, right? The sediment inside of the water will sink down to the bottom, and that's what makes the riverbed, right? So we can tell that we have different layers inside of that mixture, and that gives us a heterogeneous mixture. I'm gonna ask you a tricky one. How about air? Heterogeneous or homogeneous? I heard them both. All right, let's define our air a little bit more, because air is kind of ambiguous, right? So what if I had a closed container, perfectly sealed closed container that was filled with air, and I left it set for about an hour? Heterogeneous or homogeneous? Homogeneous. You're going to have oxygen, you're going to have nitrogen, you're going to have some trace elements, but basically all of those gases are going to come to an equilibrium inside of that tube, and it's going to be homogeneous. But what about the air inside this classroom? What do we exhale? So right in front of our mouths is going to be pretty high concentration of what? Carbon dioxide. But like over here, maybe in this open empty space, is anything exhaling carbon dioxide? No. Eventually all the gases, if we stop breathing, please don't, but if we all stopped breathing, we would stop releasing carbon dioxide, and eventually the air would come to an equilibrium, and eventually it would be homogeneous. But as we are speaking right now, it is not. So a lot of textbooks will just say, oh, air is homogeneous, right? But really, you got to kind of think about the situation you're actually in. I know it sounds kind of picky, but it's not. It's real science. Okay, so there are examples for homogeneous mixture. They use sugar water, right? But it's the same thing as ours. You had water, we had a chemical formula for. We have sugar, we have that chemical formula, and we're going to mix them together. Will the chemical formula of water or sugar change when you make sugar water? No. You're just going to have both of them in your water bottle, right? So that's a mixture. But it is going to dissolve, and it's going to equilibrate, and you won't have sweeter water at the top and not sweet water at the bottom, right? It'll be all mixed. So that'll make it homogeneous, right? Okay. All right, so let's try this. Let's classify some of these. So we need to classify the following substance as a pure substance or a mixture. Well water. I'm going to dig a hole in the ground to retain water. Homogeneous or heterogeneous? And all of these are on Moodle. All of these problems are on Moodle. So that's going to be heterogeneous. Because probably at the bottom of the well, you're going to have more dirt and silt mixed in with it. So it's going to be a heterogeneous what? Mixture. Heterogeneous mixture. Okay. Ocean water. Mixture or pure substance? That's absolutely going to be a mixture. And is it going to be homogeneous or heterogeneous? Heterogeneous, right? What dumps into ocean water? Rivers, right? So are rivers freshwater or saltwater? Freshwater. So where our rivers are dumping into our ocean water, we really have fresh water coming in. So we're at the brackish, you've heard that, right? So it's the intermediate area between freshwater and saltwater, because oceans are saltwater typically, right? And so where you have that fresh water coming in. You also have lots of other things inside of ocean water. You have different amounts of oxygen dissolved inside of it. Depends on where on the planet you are, what it is. So it's definitely a heterogeneous mixture. Cement. If you walk outside and look at the cement, does it all look perfectly the same? No. So is it a mixture or a pure substance? It's a mixture. Is it homogeneous or heterogeneous? Heterogeneous mixture. You could see the rocks in it, right? Okay, a tropical smoothie. I could go for a tropical smoothie right about now, right? A little mango in there, a little pineapple, right? Mixture or pure substance? Oh, absolutely a mixture. And it depends on how good your blender is, if you're homogeneous or heterogeneous, but I would really classify that as heterogeneous because you're probably not going to be a perfect blender. Okay. Oh yeah, and I wanted to say this. When I was doing the video, I circled A and C. I don't know why I circled A and C as being non-uniform in composition, but only A is heterogeneous. The rest of them are homogeneous. I don't know why I circled them both. I make mistakes. That's all I can say. But I fess up to them. All right. Now we're classifying. We're telling them all of these are mixtures. Are these homogeneous or heterogeneous? And briefly justify your answer. A bottle of sports drink. Homogeneous. How do we know it's homogeneous? What's in there? What makes it a mixture? There's stuff dissolved in it. So sports drinks are basically sweet salt water, right? Because it always says, oh, Gatorade has these 4 electrolytes, these ions of power, and you know all this, right? You know what I'm talking about? All they did was put salt in it. Yeah, come on. It's salt water that they put some sugar in. Not that big a deal. Okay, so it's uniform. It's uniform in composition. In parentheses. A blueberry pancake. Heterogeneous. Let's say you didn't like blueberries. Could you pick them out? You could. That would kind of be sad, but you could. So it's non-uniform. Okay, gasoline. Now, I'm not talking about the gasoline that comes straight out the ground. That's crude oil. I'm talking about your car is running low on gas. So you go to the gas station and you fill it up. Homogeneous. There's all kinds of stuff inside of gasoline, you know, and y'all know like ethanol. Like you have to be careful if you have a boat because boat motors can't take ethanol. So there are definitely other things that are inside of gasoline, but it is a homogeneous mixture. A box of Raisin Bran. Heterogeneous. Because you could pick out those raisins, couldn't you? Would be a sad, sad day. But you could pick out those raisins. I myself prefer to add raisins. Extra raisin bran. But you have to buy the extra raisin bran. You ever notice that? Because you can't just add regular raisins because they're not the same. They don't have that like coating on them. I see a few people know what I mean. A few people. Okay. So now that we can classify matter, now we have to be able to use the most beautiful thing that we've ever created. No, not really, but it's pretty cool. So the periodic table, right? So let's do a really quick refresher on the periodic table. If I want to look at one column, what do we call this column? A group. We call it a group. If I want to look at this one row, what do we call this row? A period. What's weird about period 1? How many elements are in period 1? Only 2, hydrogen, and then you got to go all the way to helium. So what about period 2? We have 2 on this side, then we have to skip a bunch, and then we pick up here on boron, right? So you have to be careful of that when you're looking at the periodic table. So whenever we look at the periodic table, we can label them by the period numbers, or we can look at groups. Period's always going to be 1, 2, 3, 4, 5, 6, 7. It's really easy. Group names have 2 different designations. Look at our periodic table in the classroom. Look at the numbering system on top. It goes 1 to 18, right? Now look at the one, this is from your book, and this is the one you're going to have on your exams. It goes in parentheses 1, 2, 3, right, all the way to 18. Or the other numbering system is we have our main group elements that are the A, so the tall columns basically. So we have groups 1A, 2A, and then we went to B, right? So we go 3B, these are all B's, then we pick up on the A's here. This is 3A. So be careful that you don't flip-flop that. If you're going to do A, stick with A. If you're going to do no A and B, stick with that. But I'll kind of give both as answers. And we know that a lot of these groups have particular names. So what's the name of our first column? Alkali metals, and the second one are alkaline earth metals. And I remember that the first one is the shorter name. The first one is only alkali. The second one is a longer name. So it's alkaline earth metals. Then we have our transition elements. These transition elements are all what kind of elements? Metals or non-metals? Metals. How did you know that? They're all what color on this beautiful periodic table? Blue. It's kind of sad that they're not here, right? But the one you're going to get on exam is this one, except that I do print it in black and white. No color. Okay. What happens as we go across the periodic table, we have all of these blue metals. What are these yellow ones? Non-metals. What about these green? Metalloids. So metalloids have properties of both metals and non-metals. They can't make up their minds. They're all over the place, right? And then the last ones we have down here, these are the lanthanide and actinide series. Together we call them the, anybody know? Inner transition metals. Metals are elements. I like to say metals because it reminds me that they're metals, right? Okay, so we have nice fancy names for group 1A, group 2A. We kind of call these metals in between the transition ones. There are really fancy names for 3 through 6, but you don't have to know them. But you do have to know halogens are in 7A, and noble gases, which I like to call the cool kids, and we'll talk about why they're cool, are group 8A or 18. Okay, so you have to be able to use the periodic table. Now, they have some elements whose symbols don't match with their names. What was one we talked about today? Sodium. So sodium, what's sodium's abbreviation? That's really freaky, isn't it? Why is that? It's what? It's Latin. It's Latin. Anybody know what the Latin name for sodium is? Guess what it starts with? Natrium. So that's where the Na comes from. So when you see some that don't match, that's why. But if you're ever looking for the elements, what could you do? You could print out your exam resources, and on the second page of your exam resources, you have alphabetical by name, not by symbol. It's alphabetical by name. So if you're ever stuck on an exam, oh my God, what is Na? You know, you got a little thing. I don't want you to memorize the periodic table. I want you to use it. Okay, I think that's it. Okay, so let's go answer some questions. So we're gonna look at each of these and we're gonna classify them. We're gonna say, are they an element or a compound? Fe. Fe is what? Iron. So what is iron? An element. It's found 1 square on the periodic table. CaCl2. That's a compound. How do I know that? So this is 1 square on the periodic table. A compound is 2 or more squares. 2 or more. And when I say squares on the periodic table, what does that mean? What is 1 square on the periodic table is an element. So you could say 2 or more elements, right? It's the same thing. Si. Element. Ki. Well, how did you do that? But Si is an element. Why is Ki not an element? I have 2 capital letters. That's how I know I transition from having 1 element to having 2. Some elements have 1 letter. Some elements have 1 capital letter and 1 lowercase letter. So if you see 2 together, you know that's a compound. Good. Okay. All right. So now we're going to supply our missing information. We know that we have sodium. What's our element symbol for sodium? Na. That's that weird one. What's another weird one? Gold. Au. Right? Yeah. Okay, so sodium. What group is sodium in? Remember, groups go up and down. Group 1. What period goes this way? 3. Is it a metal or a non-metal? It's a metal. If it's on the left-hand side, it's a metal. All right, next one. Oh, we're given 2A and 4. So let's go back. Let's find 2A. So here's 2A of a group and period 4. So go down and across. What do we get? Calcium. Come down. Calcium. Okay. Metal or non-metal? Metal. It was blue. It's a metal. Okay, P. Is that potassium? No. Phosphorus. Okay, where's phosphorus? We're in group 15. Okay, so let's go back and let's do all these both ways. If we had group 1, another way to say group 1 would be to say 1A, right? I'm going to do them that way. If we have 2A, another way to say that is 2. So if we have 15, what's another way to say 15? 5A. So we're going to give them both. Okay, now phosphorus is in what period? Go across. 3. Why isn't it in 2? It's the second element down. You're right, it's period 3, but why isn't phosphorus in period 2? It's the second element down. There's nothing in period 1 above phosphorus, right? So you have to take phosphorus and go across. Don't just count down, go across. Okay, so metal or non-metal? Non-metal. And it's easier to see on the one for the book than it is on the one on the wall. Okay, in group 5A, period 2. So let's go group 5A, period 2. So I'm going to go down and across. What do I end up on? Nitrogen. Nitrogen. Come down. Okay, nitrogen. Okay. So now we have to start combining this stuff, right? So we have MgSO4. What we want to know is how many atoms are in each element of the following compounds. So what do I have in MgSO4? What's the first element? Magnesium. How many atoms? One atom. Okay, oh, not B. What's the next element? Sulfur. How many atoms? One. What's my next element? Oxygen. How many? Four. How did you know that? Subscript. So the number of atoms of each element are determined by the subscript, SCR subscript on the element. Okay, so we'll finish this one next time I see you. We didn't quite get as far as I wanted to, but that's okay. Be all right. Okay, if you want to check the eye clicker, you are welcome to come and check the eye clicker. I'm going to end the Zoom. I don't.